debatephysics.com, debatephysics.com. Also, video presentation.
No, you don't debate.
And, yes, just more arguments. So today I saw a video and I thought, oh, great, nice piece of evidence, sliding block kind of video with rubber bands. But then I did the frame rate thing, and again, it's really kind of mushy, depending on how you count the...
Oh, that's interesting. You did the frame rates. Didn't do it on Professor Russo's experiment, did you? Dispo did it for you. Completely avoided that one, aren't you, you fucking coward?
Frames, you can get to 1.45 to 0.7,
Yeah, 1.45, yeah.
So anyway, it was just kind of disappointing that, just can't get results.
Disappointing that you couldn't break the laws of nature, yeah. You're going to be very disappointed for a very long time, aren't you?
Now, I will go through all the reasons why. I'm confident there just can't be...
Yes, you're confident, but you're fucking stupid.
There's no possibility that this silly theory, that you square the velocity makes more energy, can in any way be true. And I'd argue it goes all the way to elemental thermodynamics, that the whole idea of thermodynamics breaks down if you can create free energy by merely transferring energy.
But you're not creating free energy, are you? You argue for free energy, hence your bullshit doesn't work.
From heavy things to light things, you can just make tons and tons and tons of free energy. Just ridiculous as a concept. And I certainly know that gravity...
Indeed it is, but you keep arguing for it, don't you?
...is collected in units of time, not in units of distance. That's Galileo and Newton, and it's really solid physics. It's really easy to draw it and understand it, so I'll draw it to understand.
Yeah, but you draw it wrong and you understand it wrong. Therefore you keep being wrong.
Again and again and again and again and again, if that's what it takes. The simple thing that I actually...
Oh, yeah, the one thing you actually fucking did
make one of these experiments, for my own satisfaction. I used little weights that were stuck together with magnets, so I could do a 4-to-1 relationship, 4 times the distance, and, so you have a 4 mass going 1 velocity.
Yeah, and when you made that and you put the weights on, what happens? It balances, doesn't it? It just balances. It doesn't move. It just balances. Amazing.
And over here you have a 1 mass going 4 velocity, and it creates this kind of silly...
But again, where's the velocity coming from? It would just balance. It wouldn't move. There would be no velocity.
Circumstance where basically the claim is that there's 4 times the energy moving on this side than there is on this side because of the squared velocity. And
but it wouldn't be moving, would it?
The momentums read exactly the same. 4 times 1, 1 times 4, same thing. So it makes perfectly good sense that it balances and it oscillates.
Well, at least you could do a bit of fucking basic math there.
Perfectly. So again, this oscillates 1 unit of distance. At the same time, this oscillates 4 units of distance. Kind of easy to understand. This is 4 times the velocity. This is 1 time the velocity. And the trick is that the energy has nothing to do with this object or this object. They're always the same weight. So technically, they would always stay in any position.
But they're not the same weight, are they? You fucking moron. You've just said there's a 1 and a 4, so they're not the same weight.
You put them in. They're not fighting each other. And all that really happens is the lever itself, at that critical point where the lever pushes to one side to the other. That's what's really happening, is that mass is actually going from one side of the lever. It's being thrown onto the side of the lever.
Right, so you seem to be under the illusion here that at that pivot point, that's the centre of mass. And that there's some mass going a little bit over one side and a little bit over the other side. But in your diagram here, so if we've got the weight of the lever, that's the weight of the lever. Just, for this instance, let's just say it's massless, and you've got a 1 mass and a 4 mass. So on one side of the lever, you've got 4 times the fucking mass. So at that centre point, how is the mass moving from one side to the other when there's 4 times the fucking mass on one side? Like I say, the centre of mass is not at the pivot point. That's where the pivot point is. That's where it's restricted from the whole system being accelerated down. And if you was to snip that, it wouldn't just fall straight down. It would tip and fall from its centre of fucking mass.
It's going up. So when a part of the lever goes up, it actually gets heavier. And that's why it stops and then goes back down, is because it actually got heavier on that side. And when the other side goes up, it starts getting heavier. And
no, fucking hell. when a lever balances, so the net torque at the equilibrium point is 0. There's no net torque. So when you push the lever up or pull the lever down and you give it some gravitational potential and let it go, that mass will be accelerated down. So it has some angular acceleration, angular velocity, whatever you want to call it. But when it gets back to the fucking equilibrium point, there's a net zero torque. There's nothing to stop it. So it will continue past. And then that raises the mass up on the other side, and so on, and so on, and so on. It's got, like I say, your example here, it's not even anyway. There's no, it's not at the fucking centre of mass. The mass is not swapping from one side to the other because it's already in fucking balanced.
It goes up. So, it constantly has negative feedback, you could argue. So there's a little bit of negative feedback, and the mass is essentially just jumping from one side of the lever. This little tiny bit of mass just switches from this side back over to this side, and that's what's oscillating. Is that little bit of mass back and forth, back and forth.
But it's not. You just made that shit up. Again, the law of the lever, you don't cite it, you don't say what it is. It doesn't involve fucking momentum, it doesn't involve kinetic energy. All it involves is forces and distances, that's it. And that's how you get the balanced torques. Because you've got a 4 mass at one distance and a 1 mass at 4 distance. So you balance the torques. You get the equilibrium to be a net zero, and therefore it balances.
I can't have an oscillator, that is where the same energy is causing the effect. I can't have an oscillator that has 4 times the energy on one side of the oscillation. Can't do that. I mean, that should be something everybody agrees with. That, yeah, that can't really happen. So there's got to be something else going on here. They have to explain. And, yeah, of course, they don't explain nothing.
Why don't you try fucking learning?
They just say, Leibniz says so. That's all they know how to say.
What the fuck has Leibniz got to do with the lever?
Leibniz says so. Because it's not what Newton said. They keep lying that this somehow is Newton's physics, but obviously it's not. So in the case where people are launching things with springs, as pointed out, the big...
Ooh, launching things. Have you seen a video recently where something was launched, I wonder, and it didn't come out your way? But you're not going to mention that one because you've gone from making up excuses and, finding flaws to just basically avoiding all counter-arguments and evidence now, haven't you, you fucking coward?
So the spring's going when the thing flies off, the more the spring's going to wobble, and the slower the spring's going when the thing leaves.
And you've obviously tested this, haven't you?
Less the spring wobbles, so obviously less energy is still trapped in the spring. And so that what ruins these experiments where you're pushing or pulling something with an elastic is that it's sort of defeated by the fact that the elastic...
but it's nothing to do with the fact that it just proves you wrong constantly.
Doesn't stay compressed. So I guess a way to do this with a constant, that would be a constant acceleration.
Ooh, are you going to come up with a genius way of breaking the laws of physics? Let's have a listen.
I think of some way that you could defeat this problem, but I don't think you can.
No, you're not going to defeat the problem of talking absolute bollocks and trying to prove physics wrong. Or nature, the laws of nature wrong.
Except to, so that's worth just thinking about. So let me redraw this. So if I was to do a sliding block...
You can think forever and a day, but it ain't going to happen.
And I didn't allow the block to get up to its peak velocity, and I just measured it based on its acceleration, then it couldn't possibly...
And how would you do that? How would you measure that? Because you don't even know what fucking acceleration is.
See, this spring can only go so fast, right? So if I have a spring, it has a speed that it can move, right? So this is a stiff spring. It's kind of got a high constant, so it can move really fast. But we know that some springs, especially things like rubber bands, they're kind of,
Oh, spring... Especially like, you said springs and especially like rubber bands. So would you be, clumping them into being spring-like? Funny that, because it's not what you said previously. Because you avoided that fucking one, didn't you? Twice the stretch will be 4 times the force. Yeah, you fucking ignored that one, you fucking coward.
Move very fast, so I could take this rubber band and, maybe I could measure the speed that it goes, but it's not very fast. If I could probably film that, and, it would show that it's not very...
Fucking film it then. Test it.
So what I was thinking, though, is if you could put a barrier to ensure that the rubber band never stops pushing on the object. So say if the rubber band had a natural length here, all right, then if you were always stretching it, so if you stretched it to here, all the way from here to here, and the natural give up point would be here on this side of the stick, then at least it would never stop accelerating the object. And so you might be able to get a better definite description of twice the velocity using 2 rubber bands versus, say, 1 rubber band in the other case.
Could you actually be any more vague there? I have no idea what that was.
Still going twice the velocity. So the problem is you still need the rubber band to move twice as fast, which it just might not be able to do. So that's the limitation. So yeah, it would be better if we could do these experiments with air pressure, or some other mechanism. But all of those have their complications too. So
the thing is, you're looking for alternatives all the time to try and prove what you say to be correct, but it's not correct. So you can search and search and search and look for alternatives, but it ain't gonna happen. It's you're trying to break the laws of nature.
Brozo did do the experiment, and it did get results very distant from.
Yeah, you keep citing Stephen's experiment, don't you? Again, you don't show it because there's a flaw in it, but you keep citing it.
What is claimed by the aggressive naysayers, opposing my argument.
Aggressive. Fuck off, aggressive.
People who think this 1/2 mv squared has some sort of credibility. The people who think, like I said, let's just draw it up here again, just to be clear what these wackos, these silly people are saying. They're saying it takes 25 times the fuel, the force, 25 times the force, to...
And again, you're going to write it wrong.
To go 5 times the velocity. That's their...
So again, you've got 25 times the force, fuel equals 5 velocity. Complete and utter fucking gibberish.
Assertion about reality, and the vice versa part, that 5 times the velocity will equal 25 times the force. That'll do.
Right, 5 times the velocity equals 25 times the force is such a fucking retarded statement. And it's not what physics says, it's what you say because you misunderstand everything. This is why you keep saying it's all wrong. No, you're just saying it wrong. You're understanding it wrong.
The real world doesn't work that way. The real thing was always momentum. That's what Newton said kind of clearly. Twice the force, twice the velocity, 3 times the force, 3 times the velocity. And
again, you keep saying this, you keep misquoting your so-called idol. It's not what he said. It's what you say, and if he was alive today, he would slap you across the face. And, unfortunately, it's finding experiments that verify that. That's the tricky part. Because of the fact that all... But again, you're trying to find an experiment. You're trying to create an experiment that breaks the fundamental laws of nature. And this is why you can't find an experiment that does it, because you can't break the laws of nature. But now, the one that should work. Well, see, this one hasn't been tested either, frankly. I haven't seen anyone actually prove, this one. But, the idea of a ramp, and shooting... Wow, good idea, a ramp. Something off a ramp, and at this height should guarantee you, a velocity. Correct. If you were to go from 1 height, that would give you 1 velocity, and if you were to go to 4 heights, that would give you twice the velocity, guaranteed. That you'll get your mgh value, on the ramp as a rolling velocity. Now the question is that true? Because the fact is that it will have a bunch of angular rotation. Well, again, you could test it, couldn't you? So we know it rolls at different speeds depending on where I put the mass. If the mass is on the outside of the object, it'll roll a lot slower than if the mass... Yes, it does, but you could use the same probe in both experiments. Take 1 to 1 height and take it again to 4 heights using the same probe. So that wouldn't matter, would it? It's on the inside, near the center of rotation. It'll roll much easier, and it will complete the task of rolling quicker. Now, what speed it'll be going when it finishes is the question. So the acceleration will be at a different rate because there'll be a different proportion of the acceleration converted into
the portion that's going to be
I don't know what you're on about
in the
now.
rotational angular motion. So if we can make them slide
Oh, slide, yeah,
instead
that's
of
not
roll,
a bad idea.
then they should fall at the same rate. So that would be an interesting way to do it. But regardless, let's just say that for the sake of argument, 4 times the height will get you 4 times the velocity. I mean, twice the velocity,
It's not for the sake of argument. It will. It's a fact of nature.
which is what we're after. Then clearly they're going to argue that twice the.
Yeah, then clearly this experiment would perfectly prove you fucking wrong, and you've just realised that, haven't you? Because that's how much of a fucking retard you are. That you've just described an experiment to try and prove yourself right, and in doing so, you've proved yourself wrong. Because you're either fucking completely fucking stupid, or you're a lying cunt.
Velocity is 4 times the energy. But obviously, if I do launch with twice the velocity, it's just gonna go twice the distance. It's not gonna do anything else because I'm not taking the energy out. So that won't prove anything at all.
Oh, it would prove something, because you, like I say, you realise that as you're drawing on your fucking whiteboard, that you've just gone, oh shit, yeah, that actually proves me wrong. Oh fuck, I best just skim over that one.
Yeah, so that won't work. That won't do any good.
It would actually work great, but again, it wouldn't. It's not the result you want to see, so therefore, it wouldn't work.
So we have to have twice the velocity. So we'll have twice the velocity when this flies off the end here. It gets to us. So again, it's just basically we have to have it hit something that we can depend on. And yes, you can depend on collecting with a spring. You just can't release with a spring. So frankly, we should be able to measure it with a scale.
Yeah, and I've done that, and other people have done that, dropping masses onto a spring, collecting the energy, and it's perfectly in line with the kinetic energy formulas and the energy formulas in general.
So you should be able to do this into a scale. Just do this dropping thing from 1 unit of height and 4 units of height, and you should be able to detect twice the velocity should be twice the compression of the.
All been done, all been shown to you. You just pretend like it doesn't happen now, rather than just dropping it straight down. You want to add a ramp into the mix like that's somehow going to get you the results you want, when you've just realised it won't.
Right. And so that's doable, I guess. Yeah. But it's always just better if we just find some way to measure how fast something's going and then just do the experiment with a timing gate and just, do the experiment lots of times.
But that has been done time and time again. Dispar's done it loads of times. Steve did it with timers. You've seen timed velocities, Professor Russo, even though you said, the software's fucked up and whatever, he measured the velocities with timers very accurately. It doesn't matter what people use. You just change the goalposts. You use timers. Oh, we don't want timers. We want frame counts. You use frame counts. We don't want frame counts. We want timers. Whatever we use to show you the truth, you just can't fucking handle it, can you?
Just wait for the one that's twice the speed by, just by chance. You've got it the right speed. That would be the easiest way, I think. Simplest. Yeah, would be my choice. All right, so yeah, I haven't advanced. I'm still stuck just trying to think of these different ways to do the experiment where you can get rid of friction. And
like I say, you're stuck in trying to think of ways of doing it to come out your way, and the only way that will happen is you will have to cheat. You will have to cheat the laws of nature. You will have to change some mass, some velocity somewhere. You will have to cheat to get it to come out your way. And we will spot that a fucking mile off.
The problem of pushing something with something that doesn't.
Yeah, see, you now you're like, oh, how are we going to do, yeah, somebody's already done that, somebody's already done that one, and we've already done that one, and somebody's already done that one, and I've seen it, and I'm wrong. And this is the thing, now you're struggling to come up with new ideas, because all the ideas that you've come up with, between us all, we've done and shown you, and you're wrong.
Capable of producing the proportional amount of velocity. So, yeah. All right, so I'll just do the real quick argument about gravity and then get out of here. Just to verify why I am so confident and why I know.
Oh, God, here we go again with a fucking gravity argument. well, again, not an argument. Let's say, here we go again with a complete misunderstanding of how acceleration works.
I know what they're arguing isn't true, okay? And I know it for this very good reason.
You know it isn't true. That's it. You just know it, do you? Not you've got any proof, not you've got any experimental proof, no theoretical basis for it, but you just know it to be true. I'm sure, that's how physics works, and that's how we've got to the stage we're at, because people just knew that's the way it worked. They felt it in their little hearts.
All right. So something falls in gravity, and it falls this 1 unit of distance, and that's going to be 1 unit of time in both of these experiments. So these are the same masses. So this one's being dropped from 4 times the height. All right. So, and there's no doubt about what's going to happen, in terms of this experiment. There'll be a certain unit of time. Now, we could make this, so this is 1 second, and this is 4.9 meters of distance.
Yep. So far, so good.
And it'd be going 9.8. So we could say all that. So we could say it hits the ground going 9.8 meters per second is the velocity per second, not per second squared. And it will travel for...
No, you just said it hits the ground at 9.8 meters per second. That would be its velocity. That's what velocity it would hit the ground with. It's not accelerating anymore. So it's not 9.8 meters per second squared, because that's an acceleration. It's hit the ground with the velocity it was going, and it stops.
4.9 meters in doing that. And that'll be exactly this, 1 second. So it'll be 1 second of time. So this will be 1 second. All right. And this is going to be 1 second. And do exactly the same thing, 4.9. And it'll be going 9.8. All right. So that's what you know.
Yeah, but it started at rest, and it's accelerated up to 9.8 meters per second in 1 second. But because it started at rest from 0, and it had to accelerate up to that velocity, it's only covered 4.9 meters.
Oh, that's what you're starting with. And then you absolutely know that if I turned off the gravity, I'm going to get these two things will already happen.
You absolutely know if we turned off the gravity. I mean, again, what kind of fucking statement is that? How can you turn... It's not even a fucking thought experiment. It's a stupid fucking thing to say. We can't turn off the gravity. It's ever present. It's ever acting on everything. Constantly accelerating everything down all the time. It doesn't turn off.
This 4.
It doesn't even turn off when you go really fast linearly through it.
9 and this 4.9 or the 9.8 I have here. That's my velocity. I've already got it. So I'm going to travel this 9.8 without any, even if gravity was off.
Yeah, but but you can't turn gravity off. Gravity is an acceleration. So you're saying at that point it's going 9.8. So yes, if there was no further acceleration acting upon it, yes, it would continue to go at 9.8 meters per second. Therefore, in the next second, it would cover 9.8 meters. So by your logic, in 2 seconds, it would cover 3 units of distance, but it doesn't. It goes 4 units of distance because it's constantly accelerating.
That's how far I'll be right here. If gravity turns off, I'd be right here because that's the velocity I've gotten. So this doesn't require any...
But gravity isn't a velocity. It's an acceleration. It is 9.8 meters per second of velocity accrued per second. For every second, the velocity is increasing by 9.8 meters per second. It's not a velocity in itself. It's accelerating.
I don't need any extra force to do this part of the voyage. And the only thing I'm going to get in this next 1 second, so this...
You're not going to get any extra force. From when you drop it from here, there, you get the same force acting upon it. Because it's... Oh, fucking hell.
whole thing will be 1 second. This whole bit here will be 1 second. So it's 1 second to do this, 1 second to do 3 times that. 3 times. And the only thing I'm going to get is this. I'm going to get this. This will be the only thing I get in that second. I'll get the 4.9, same thing I got in the first second, and I'll get the extra 9.8 added. So now I'm at...
But that, again, that makes no sense, what you're saying there. So you're saying it goes 4.9 meters per second in the first second. It goes 2 units of 4.9 in the second, and then you gain another 4.9 when we've already done the 2 seconds. You're all over the place. You're making absolutely no fucking sense. Again, you just don't understand what you're talking about. This is why you're so confused by it all.
19.6. So we know this is all time dependency. This is twice the velocity. Okay, it's twice the time. It's twice the weight. It's twice the force. It's twice everything. It's not 4 times anything.
Twice the time, yes. Twice the velocity, yes. Twice the force, no.
There's no 4 times anything there. I didn't collect 4 units of energy. I didn't collect 4 units of gravity. I only collected 2 because gravity...
Oh, units... Oh, God. The same force is acting on it. It's falling through a distance. Force times distance is equal to energy. It fell 4 times the distance. The same fucking force over 4 times the distance. 4 times the energy.
It isn't 9.8 meters per second squared. It's 9.8 meters per second over 1 second. That's what it is. All right, you don't sit there and take this
Yeah, you can write it that way, but it means the same fucking thing.
second and this second and multiply them times each other. This is 1 second. This is 1 second. Okay, you can't multiply them times each other and call it second squared. It's just wrong. Yeah, it's absolutely wrong. 1 second times 1 second is 1 second. It is not second squared. All right. So that's why I'm confident. It's because I know that's correct. I know that's how Newton understood it, and that's how Galileo understood it, and they...
But you don't understand it. I mean, the thing is, what you don't understand when it falls that first 4.9, at that point, it's going 9.8 meters per second. That's its velocity. When it gets to twice the distance, or root 2 the time, it's no longer going 9.8 meters per second. Its velocity has increased because it's accelerating. So it's roughly, twice the distance. It's roughly going 13.9 meters per second. And then when it gets to 3 times the distance, it's roughly going 17 meters per second. And then roughly, well, not roughly, but when it gets to 4 units of distance, it's going twice the velocity. It's now got to 19.6. It's increasing as it falls. It's increasing in velocity as it falls, and therefore the faster it's going, the more distance it's going to cover in the same amount of time, because it's moving faster. It's accelerating. It doesn't get halfway and then just jump up to twice the speed, or as you're saying here, it falls 3 units of distance, and then on that last little bit it goes, oh, I better catch up and just get up to twice the speed. I mean, absolutely fucking retarded.
Didn't believe any of this much. I mean, this is an amazing thing to assert. And to think that Newton wouldn't mention it anywhere in his entire...
It is an amazing thing to assert by yourself, because nobody in physics asserts it, because it would be retarded. But you keep asserting it.
Arguments about all of the physical dynamics. Like, nowhere he mentioned this tremendous capacity to increase energy this way. It's ridiculous to say this is Newton's physics. It's not Newton's physics.
But again, well, forget it.
It's Leibniz's physics. It was argued for 100 years. Unfortunately, they didn't have any good experiments 300 years ago, and they still don't have any good experiments now. So that's the part.
Yeah. You've seen plenty. Obviously, these things have been done over hundreds of years and are well established. And for whatever reason, you just, I don't know, you can't attack reality.
That's just really disappointing. And I guess it's going to be up to me to try to do these experiments, but because there aren't any other honest players looking for the truth. But
well, like I say, I wait for the day when you come up with an experiment to prove your bullshit, because like I say, you will have to cheat, and we will all spot it.
I'm just confident from life experience that I know, I'm not going to get 25 times the light out of a light bulb.
And again, this life experience thing, test stuff, actually test the physics, test reality, rather than using your life experience, which is obviously nothing to do with physics.
by putting 5 times the force in. Ain't going to happen. 5 times the electricity isn't going to get me 25 times the photons. That crap doesn't happen. All right, being that there's no chatters and it's late and I still don't feel good. Yeah, it's been a rough.
Yeah, you don't get many fucking views or interaction now. I mean, the thing is, you block everybody, don't you? Everybody, you know, this is DraftScience and debate.com or whatever, and then when somebody basically debates you, what do? If you don't agree with me, I will block you. You know, that's it. That's all you've got. It's like, basically, come here, pat me back, cheerlead for me, otherwise go away, and if you don't, I'll block you. If you don't agree with me, I will block you. So that's not a debate, is it? That's you sitting there basically saying, I'm right, and until somebody says, you know, I'm right, I'm not gonna engage at all. Which is pretty fucking pathetic, really.
All right, so I'll see if I can find some other experiment somewhere. But I'm just saying that all these little experiments do add up to a pretty convincing argument.
Yes, they do, that you're fucking wrong.
I mean, the balance says momentum is conserved. You really can't not...
The balance. I don't know what you think a balance is, but if it's balancing, it's not moving, is it?
Twice the input force, twice the velocity. And that's it, not 4 times the velocity.
And again, you keep saying this, but no. Twice force, twice acceleration.
Velocity. Not anything, no evidence that it's 4 times the energy. It's just twice the velocity, twice the momentum, twice the energy, twice the work, twice the force, twice. All right.
Yeah, because you know, don't you? You feel it in your heart.
So, till the next time and such, and so forth and whatnot.
Yeah, bye, you fucking moron. Well, what an absolute load of fucking bullshit that was, yet again. Try manning up and tackling some of the evidence. So we've got Ian's done the spring, you know, added the extra springs, doubled the springs up. You've seen that, obviously. You don't like that. I showed you the stretching the rubber bands. You haven't addressed that. Again, you made a clear, definitive argument that this is what would happen, and it doesn't. You called Professor Russo's experiment a fake and a fraud. It couldn't possibly be going the velocity it was going because of the times, blah, blah, blah. You said yourself you were going to do a frame count. You didn't do that because you're a fucking coward. Dispar did it for you. And again, you've avoided that. So you've gone from, like I say, calling evidence rubbish, fake, flawed, whatever, to just flat out avoiding it now. You're just flat out being cowardly because you've got no answer to what you've seen apart from saying, do you know what? Yeah, you're right, guys. I'm wrong. I got it wrong. And that's the truth of it. So now you're just avoiding as much as possible because you can't admit defeat. But like I say, you carry on. You do your experiments. We're all looking forward to that one. Because like I say, your experiments are... yeah. But like I say, you're going to have to cheat. And we're going to know. So, that's it for today. So, we'll leave it there. Happy New Year to everyone. Thanks for watching.